So I have started recording. Can you guys still hear me?
Yeah.
Awesome. Ali, I don't know. Are you using a earbuds? Are you using earbuds? We are getting like lots of feedback from your end. Maybe something is connected to your phone. All right, let's try to kick this off. Here we go. So, I currently have my code editor open. Just let me know if you can see my code editor. Now,
Yeah, we can see.
all right, thank you. There we, where are we? Where are we? Smart projects, ink workshop. All right. So I want to do something very simple. I basically want to show us how to do cross contract calling using ink. I don't want to really dwell on the beginner stuff now, but ink is basically a smart contract programming language written, and it's entirely Rust, right? I think it's called an embedded domain specific language, right, of Rust. And what we are going to be using is the version 5.1, I believe, of ink. And we are going to try to do some cross contract calling by following the instructions in the documentation, right? So let's go. Let me copy this file out of here. Okay, let me just add it. So first off, I want to open my node, the local node I'll be using. Right, and this node is going to basically simulate a real life node, but it will be running on my local computer, and this is where I will deploy my contracts. And we have our node here. So I downloaded this node from the release page on GitHub, official Parity release page, and I made it executable, right? And now I'm going to run it. Substrate contracts. Right, yeah. So we have our node running. Next thing we are going to do, I want to do now is just open my sample contracts, and we have it in here. I was supposed to have moved it into this folder, but I was kind of in a hurry to do stuff. Okay, you know what I'm going to do? I'm going to move copy one into the folder, actually. Here we go. Good. Everything good. Now let's go. Please, in case you can no longer hear me, just please find a way to let me know, or if anything goes wrong, because I can't see Discord from here. All right, so this is the template from the official ink examples, right? And yeah, so we are going to use these templates basically. Now I'm supposed to show you people my slides, but because I'm in a bit of a hurry, or I was kind of rushing to put this together. It's not complete, and I don't want to show it now. And I also believe we can do this without the slides, because we will basically be following most of the things in this code base, and also on the documentation. or in the documentation. All right, so there are two major ways, according to the doc, to call contracts, right? To call another contract from within your own contract in Inc, right? One way is using contract references, and the other way is using these builders. Now, today I would like us to focus on one specific way, which is using contract references. So, for two reasons, right? One is that it will be for the sake of time and basically just managing our learning process. It will be beneficial to focus on one. And secondly, I have actually not gone through the second one properly. All right, so moving on. The way this works basically is that you reference the second contract, the contract you want to call, using its code hash, right, in your first contract, which is the caller contract, right? And then by so doing, they become linked, right? Then you can call one contract from the other. Now, this is the only downside to this, right? The downside, or one of the downsides, is that you have to import the contract. Now, why is this a downside? I'm not sure, but I guess it means your contract might be a bit bloated, right? That means the contract you are calling. We are talking about maybe higher compile time and the likes, maybe affecting performance. All right. So these are the steps, right? First step is to prepare the contract to be imported, right? So how do we do this? Opening my VS Code. Then we go to this contract, order contract, and we look into it, right? So this is basically a standard Flipper contract for Inc, right? And if you've looked at Rust codes in the past, you'll see that. Is that someone trying to call my attention? All right. So if you've looked at Rust codes in the past, you'll see that this is basically Rust, right? But there's something different here compared to other contracts. We are exporting these contracts, so we are making it available for other contracts to use. Right, so that is the first step. Export the contracts. Now, secondly, what do you want to do? Now you want to import the contract you just exported into the contract you want to use to call it, right? And this is how you do that. In the cargo.toml of the contract you want to use to call it, you need to do this, right? You need to import it as other contracts. You put in the path, and you also need to add this feature, this piece of, let me call it code, right? Now let's look at this important information. Two things to note here. Number one, if you don't want to get linking errors, you have to ensure you specify this. Then secondly, this part, we need to ensure that we need to enable STD, right? No, that's not STD in medical terms. This STD means basically standard library, right? The Inc standard library. So we need to enable it in the cargo.toml. Otherwise, we will not be able to generate the metadata of our calling contracts. All right. So that's the second step. So let's look at this in our code. Now, remember, this is the basic contract caller. These are our calling contract, and in our calling contract, we have our order contract, which is the contract we want to call. Now, the lib.rs of our order contract is open, and we exported this. We exported it out of. We basically made it public, right, so that other contracts can use it. Now, going into our calling contract, the lib.rs of our calling contracts. Right, and actually I want to start from the cargo.toml. We'll see that this has been done, right? We have basically imported order contract, first of all. And also we have enabled std here. Okay, are we good? We've enabled std here. Good. Now, on the next step, we want to do this. So we want to basically use the code hash of our order contract, right, to instantiate our calling contract. Right, so this is what we are doing here. We are sending this in as an argument, constructor arguments, right? And we are basically instantiating our calling contract with that. And after doing that, let me just show you that in our code base. So this is basically it here, right? And so once we do that, then we can reference other contracts here. So since we passed this as an argument, we have it available here, right? And everything is basically instantiated. And what is happening here is basically it is being outputted, right? How do they call it again? Returned, right? And we are saving it into storage here in the structs. Okay, so now once we have access to other contracts in our storage, right, we can manipulate it. Basically, we can flip it. We can also read its state. All right, and we can also get its account ID. So let's do a quick demo of this. Here we have our node up and running, and what we want to do next is deploy things. Now we have to deploy the contract we plan to call first. So how do we do that? I was in the process of trying this out, I noticed that the best way to do this is to use pub CLI, right? This is the pub documentation here. And why did I say this is the best way? I tried using cargo contracts and it practically did not deploy. And pub CLI works well. And so in order to use pub CLI, you just have to install it, and then you can use the commands. I have previously installed pub CLI, and so the command for deploying is pub up. Now, looking at our other contracts, we'll see that it takes in an argument. It has a constructor argument. This means at the point of deployment, we need to pass in an argument. And we are going to pass in the argument true. We instantiate it to true. So what pop-up does for you, right, which makes pop a nice tool, is that it builds it in release mode. It builds your contract in release mode. It uploads it to your node, and it also executes it, right? And so your contract becomes your contract state becomes stored in your node. So we are going to do this. This might take say 2 minutes ish. Okay. This is the thing with Rust. It's the time. So it's doing a number of things in the background, right? Which probably being, obscured or hidden from us. So that's why. If you are using cargo contracts, you'll probably be seeing some interactive, some things being generated in the CLI. Yeah, just wait a bit. And while we wait, I guess I can show us how to install POP CLI. And the reason why we are using POP CLI is just what works. I tried a number of tools and I was getting errors, frustrating errors. Okay, so this is where you come to see how to install POP CLI on your this is how to install POP CLI in case anyone is interested. So going back to this place, we are still building. Okay, deployment field. Yeah, excuse me, we did not cd into our my bad. So let me remove this. I'm removing it because I don't know. Go. So we need to deploy. So what just happened there is that we could not deploy the calling contract because we have not deployed our other contract yet. So one needs to be done before the other. Just trying to keep things organized. Alright, let's go. So let's try that again. Yeah, this card is so funny. If people leave, it makes so much noise. We are going to add this into okay, so we are going to do cd into the other contracts. And first things first, yeah, we are going to call our this again. Apologies, we have to wait a bit more. Alright, I feel that this might be faster because it's actually working. Okay, sorry for the breaking transmission. Alright, so what else should I show us while we wait? Excuse me. Alright, so this is the main command to install pop CLI. Okay, and the other ones at the top is basically just to prepare your Rust environment. And another thing I'd like to show are the commands for using pop CLI. Alright, installing. Let's look at the commands. Install. Yeah, this pop up, which is what we are using here. Okay, our contract has been deployed. Better conceptualize it. Now, I want to so we ought to first have deployed the contract we want to call before we can deploy the calling contract. I'm sure that makes sense. Now we're using pop up. Now, looking at our calling contracts, we see that the constructor requires the code hash. So that's an argument. Args. So we are going to import the code hash. I'm also going to try to use a salt here. And I'm going to put a random X value as a salt in order to try to get a different address. Alright. Now while we are doing this, I'll go to our contracts UI. Now connect to local node. Alright, so remember the first contract we deployed is other contract, which is a Flipper contract, a standard contract in Ink. I'm going to come in here. We are going to upload this. So we are adding it to our UI from using the contract address and the metadata and WASM block, right? Because we've already uploaded it and deployed it on the local node, right? So when we impute our contract address and we impute this metadata, let me call it metadata to make things shorter, then the UI can recognize the contracts. And this is giving us a different contract hash actually. Interesting. And so we can different contract hash. So we can upload and instantiate. Let me take that again. Use on-chain contract address, because that thing is showing me, it's just funny. And I'm going to use this contract address. Copy again. going to name it other contracts. I'm going to upload this. Yeah, I hope we're in the right place. To just be sure, I'll go back. Okay, add contracts. Yeah, so that was the wrong step. So we are instantiating from an existing contract address, right? And remember when we deployed it, we instantiated it with the true argument. So we said it should start with true state. So it's currently on true. And now we are currently deploying our basic contract, which has been deployed, right? And so we are going to go to a node. We add that to use an on-chain contract address, paste it, we'll name it. Now this naming does not really affect it, but it's just for your own use. So in other words, if your contract is called Flipper when you deployed it, and you named it, and you name it other contracts, it should not affect anything. And take this one. We added there. All right. So how this is supposed to work is this. So due to the fact that we have embedded our code hash into this contract, we can flip from here and we'll get a result here. Right, so we'll be flipping this and it will be flipping our other contracts. Right, so let's call contract. So it has, now, you know, this contract does not have, it does not have a flip value in it, the basic contract caller. It does not have anything, it does not have any Boolean value that allows it to flip things, right? But we've been able to successfully flip the flipper contract. So it started with false, but now it's true. Now we can flip the flipper contract again, like flip and get, flip it, and we flipped it to false. So let's try something else. Let's try to deploy a random contracts. Okay, no, that will not work for this. That's using the build method. Okay, yeah, so in summary, this is how you do this. This is how you do a cross contract call. Now, apologies for all those mix up earlier. I think I basically missed the way it works, and I took us through that long journey, right? So I would let me just try to go over what I just did now, right? So this is a contract. Let me take it down, an in contract, and look at this in contract. You see that it does not have a Boolean value in it. For example, it does not have anything that says true or false. I don't know if anybody, so for people that are familiar with Rust, they will understand what I'm saying. It does not have any value that says true or false, right? But if you come to our UI, excuse me, you've noticed that we are flipping a true or false value here. So the question is, how come? How are we able to do that? And this is because we are using cross contract call through references, or true reference method. Now, how do we achieve this? We basically imported another contract into this contract, number one, and on deployment, we deployed with this, with the contract, the imported contracts code hash, right, as a constructor parameter. I'm sure the more curious among us would be thinking, okay, what does this thing stand for? And my honest answer is I have not looked into it, but these are definitely possibly some ink specific functions, right, that kind of enable this to work. But one thing is for sure, this is our contract hash, right, and we're passing it into this function, and we're also and the values that are stored in this variable is being returned. The value stored in this variable is being returned if it's one value, if it's more. And also we are then storing the reference to this. We are storing it in our state, right, for the contract. And another thing we are doing is this. We are exporting a reference to this contract, to the contract we want to call, the imported contract. Now we are exporting a reference to this contract, right? And secondly, another thing I want to note is that I'm currently using Pop CLI, and because it seems to be the one that's working for this now, there's some of active development on Ink, so a few things might not be working optimally right now, but lots of progress is being made. But yeah, this seems to be one that's working for this now. And also I'm using my local node, and that's the substrate contracts node. I'm not sure if I'm missing any other thing, so I will just open it up for questions. I feel like some things might have been mixed up, so if you have questions, please feel free to ask me.